Now that we know how to mark the artifact and then how to mark comments, we can just review the data. Let's go to this virtual recording. Let me take you to do two most important, two most important features of BESA, which is you can see or else review the data with the fast Fourier transformation very, very easily. All you need to do is just select the segment just like this. You can right click over here and press FFT, or you can just click press F on the keyboard, which is going to show you the frequency decomposition of the data. So here, as you see, there is an eye blink over FP1, FP2, sorry, FZ, FP2, these three channels. So we know that that is a low frequency activity, which is being projected or else shown as a frequency spectrum, amplitude frequency spectrum with these channels FP1, FPZ, and FP2. You can also see it in terms of frequency. It is in the lower cut frequency range. Now, if you want to see what is that, where these frequencies come from, all you need to do is double click in that frequency and just use the plus up arrow, and you can see it is coming from, this frequency is coming from this part of the head of the brain. Yeah, that's what I wanted to show basically from here. Next, you can also see the same thing in terms of power. All you need to do is just click over here in terms of power, and you see the majority of the activity comes from FP1, FPZ, and FP2 again. So now the unit would be microvolt squared, and the left side, it is showing you the maximum frequency in that channel during this period. But we need not be restricted only to this small section to compute the fast Fourier transformation FFT. Instead, you can also do the mean FFT of the whole EEG data. All you need to do is just go to this process, click on mean FFT spectrum, and with this, choosing these parameters on what epoch length you want for each block, you can compute the whole data's what you call fast Fourier transformation. Also with BESA, you have a feature to export these what you call FFTs into other formats wherein you can use them using Excel sheets also. All you need to do is go to File, Export FFT Data, Power in Bands. You can also view Power in Bands. So depending on the values of the delta, theta, alpha, beta, gamma, which are in the data, you will see all these parameters which you can easily export and perform quantitative analysis of the data that you have if you are interested in both the power spectrum as well as the what you call amplitude spectrum. Here you can choose the montage with which you want, and depending on the montage, you will get the data in that fashion. Next, I wanted to show you another important feature, which is the DSA chart, which is density spectral array chart. Just by clicking the DSA, the software performs a spectral analysis of the entire EEG data, and shows you in a compressed format with 2 seconds epoch. Each block will be of 2-second epochs. Let me just do that. It might take some time. I press this DSA now. There you are. Here you have the whole data, and depending on the quality of your data or as the content of your data, you might see the variation in the spectrum of the data. So this would be very useful for those of the clinical users who have seizures recorded in the data. This would be one of the main usage wherein the doctor or else you need not, review the whole data. Directly you can go to the onset of the seizures by looking at the high amplitude that comes over there. Or, I mean, over any part of the data which has seizure. So when you see the activity somewhere and you want to go there, all you need to do is just click there. And this is going to take you to that region. See that? Just clicking will take you to that part of the data. Next, what I want to show you is that you can also see the same DSA, density spectral array, using different ways of seeing at it. Here you have different regions of the brain. This is left frontal. This is temporal. This is sagittal. So depending on which way you wanted to see, you can see those same data. And you have lot many, tools here with which you can use. You can get it normalized. You can take a percentage view. You can see it in different ways that you want it.